I'm ready. I'm here.
Okay, a couple of things before we jump into this interview. So, the bulk of the interview today is going to be us working through a question in this shared document. Just to let you know, please write in whatever language you feel most comfortable in. There's syntax highlighting for a lot of popular languages in the upper right corner of your screen. And if you want to write in one that's not there, you should feel free to change the language. Another thing to note is that we're not going to be running your code. Um, and one last note is high-level advice for what we're looking for. We really value clear and correct code here. So by default, I'd like you to focus on writing efficient code right off the bat. And I'll leave a chunk of time at the end of this for any questions that you've got for me about the interview process or whatever is on your mind. But otherwise, do you have any questions about what I just described before we get started?
Nope.
Okay, perfect. I'm going to copy the prompt into the coder pad. Are you able to see that?
Yes, I can.
Okay. Today we're going to be dealing with unit conversion, and specifically, I would like to ask you to write a program that can answer unit conversion questions like how many meters are in an inch, given a big list of conversion facts about units. So, for example, I'm going to paste right now, I just pasted in some facts and queries in the coder pad. And a few things to take note of is the top has a list of effects and the bottom is a list of example queries that you can use. You might be able to answer these facts and you don't have to do any parsings. So I'm going to pass the facts to you as a string float string tuples, and the query is a float string string tuple. Do you have any thoughts on how might we write a function that will be able to answer these queries given those facts?
So basically, the question here is asking me to parsing the facts in the above section where, it has a list of tuples, right? Like from unit to float and then to unit, from unit to float and to unit. And then I'm going to using these facts to answer queries that will take the float string as the input to give answers, what is the targeted, like conversion rate, is that correct?
Yes, that's correct.
Okay, cool. So my thinking is that, so this is basically is trying to construct a graph, which is, forming the in which in this graph, like where each unit is a node, and the weight of the edge connecting from one node to another is the conversion rate, which is the float here that's representing the conversion rate. And the question itself is trying to finding a possible path from the input node to the source node to the destination node, and then calculating all the multiplication of all the edges along the path. And if I cannot find any path, then I will say showing is not convertible. Does that sounds good to you?
Yeah, that's
Cool.
perfect.
Cool. So I would start on. So I think there's the plan is that there will be three part of this. One is so I mean testing this. Okay, so it works. So the first part is basically, building the graph based on the fact. The second part is that is using these facts to answer, to convert providing an interface to convert the query. And the third part of it is, like running the test, and do the graph traverse, on top of it. So I'm going to writing that, from the start. So the first one is going to be, parse. I'm going to write in the interface first. So I'm going to parsing the question. So parse the facts, then the facts. And then the next part is I'm going to query the float, basically the entity convert entity into unit based on the facts. The test case we are going to do is, in this case, is assert so basically we'll print the the list of question here, which is basically two sorry, and meter, and the destination is inch. So and so well, so we'll do this like facts string. This is conversion graph. So I'll do conversion. This is a axis array. So you mentioned this is going to be a tuple that I can use.
Yes, a tuple, yes.
And I'm going to do a bunch of other test cases as well. Be 13 inch and meter here. The third one is 13 inch. And so that's probably the setup of the my coding, like solutions here. I just want to check, does this make sense to you?
Yeah, this is good.
Okay, cool. So what I'm going to do next is that I'm going to um, basically implementing each of these functions and and then trying to like implementing this one and then like checking a few different uh implementations and then different test cases to verify the implementation. So okay.
Mhm.
So what I'm going to do next is to um first I'm going to creating copy down the facts into, so it's going to be, so meter 3.8 feet bit inch. So, and second. So, and in order to construct the facts into that, I'm going to using a a graph representation of it, so there's two choices that we can do. One is that, like I can creating a graph that is using the adjacent link like dictionary, and or another one is using a graph metric. So I in this one I'm going to using the adjacent link because it's probably going to be a sparse matrix here.
Hmm.
um so here's going to from collections import click, and so each node will point into uh, the unit, and and managing the weight. So as a conversion cells, and uh, unit to unit, and factor weight. Graph from unit and to unit. So this will add the node on both ends. And I think it's also important to notice that, because, weight unit conversion is, like two ways conversion. So once we have, like the one way, like fact, we could, construct the other fact as well. So it's a bi-directional graph.
Okay, nice.
Wait, just note, I'm now going to check in um, like the safety here because I assume the data will be clean, but in a real practice, I probably will do that to check in, it won't have zero in these cases.
Okay. And just to clarify, you said that this process is to make sure the graph it becomes bidirectional. Is that
Yes,
correct?
yes, yes.
Okay, okay.
And so now I'm going to uh, using a breadth first search to like look up any like pass exist when given like a self unit and two unit direction there. So what I'm going to do is that it's like find and two unit. In this case, I also need to have the quantity. Or what I can do is that I could just return the factor and then multiply that quantity at the end of it, so which is fun as well. So what I'm going to do is that I'm going to have a visited set and also a queue that's managing what I'm going to visit next. So um, what I can do is like this. So I basically can do this as I can pass the initial factor in as well, the quantity EQ from unit and quantity. Need to import. Okay. And quantity. So in the end, what I'm going to do is that it's like while the queue is not empty, so I'm going to get the current factor equals the queue. And if current equals to unit, or just a return current factor. Job done. If not, we'll put visited this into the visited node. And for all the neighbor in this node, if neighbor hasn't been visited before, and will append basically the neighbor, the current factor multiply the weight from the current node to the neighbor. So see, so the neighbor factor weight. So this is probably the. So this is the weight, and then the weight. So this is just to quickly check the. So self weight of the current node and the neighbor node. This should be
Yeah, can you
Super.
describe what your process is right now?
Yeah, so what it does is that, like this is a breadth first search of the graph. So it basically will looking at, if the current node is already the targeted unit, then we'll return the factor. If not, we'll add the current node to a visited node history, and then looking at all the node it can reach. And then if the node it reached hasn't been visited before, we'll append the neighbor and the current value accumulated multiplied by the current weight to
Hmm.
the next node, to be visited. So that will be added to the queue. So that's
Okay.
the process here. And um, if not, well, if we cannot find anything, we'll return not convertible. All right. So I think this is going to be the process. And for parsing the fact, well, basically saying it will return. So it will have a graph equal unit graph, and it will for each fact in. So basically, what it will do is it will for each tuple in the graph, in the fact for the uh, from unit float, the fact and to unit in fact. So we'll add this one to conversion. So from and to unit and then fact. So this will construct the graph and then we'll return the graph. And then when uh, this happened, when this is the one, well, convert haven't, we'll return graph, find the path, and given from unit to unit and com quantity it wants to convert. So basically this is so the functions will work like this way, and it will pass going to test it. We're going to pass the fact to the first question, and then we'll also yeah, run the following code. Let's see how it goes. So in this case, it will return 78, 72 and 0.330 and and also not convertible. Since there's a miss of a mark here. Yeah, that's it.
Okay, cool. And that also perfectly wraps up our interview today. I mentioned in the beginning of our session, we now have time for a few questions. Did you have any questions for me before we end?
No, that's it. Thank you so much.
Cool, thank you. My first question is approximately what percentage of Synco's suggestions did you utilize during the last interview?
I probably have used, like probably up to 60%, I mean, I would say probably 60% to 70% of my answer to the interview question. And then for the answers, Cinco gave me, I probably only leverage, probably 10% of all the output. I only take the most, the highlighted part that I can quickly scan through from the suggestions.
Okay, nice. Did having Cinco during the interview make you feel more confident or anxious?
Um, it's it makes me more confident definitely in this case because I kind of have a quick idea of how where this interview direction is going. And but by quickly scan through what Cinco suggested, I kind of feels like I'm on par on the same direction what the Cinco the AI is thinking, and then I can cross-validate my thinking when solving this problem.
Cool. Did you find Cinco's UI distracting at any point during the interview?
I I think it gives me a little bit too much of suggestions while we are going through. Like I like the code highlight part, and it's like very accurate and very good. But also I feel it gives too much information for me to go through. It's very hard for me to looking through everything. Like while I'm answering the question and trying to solve the problem.
Okay. What is your personal assessment of how the interview went?
I think I did the problem solving part pretty good. Uh, the real challenging is that while I'm, being solving the problem, I also, be getting, like a little bit of, scanning through single suggestion and then trying to getting things right. So I felt like, I probably haven't explained more on my thinking process, like how I approached it. But I do think, I gave my high level thought, like at the beginning, that's, which I believe is correct. And then, like I just jumping into the implementation, which I felt pretty confident after I see Cinco's recommendation.
Nice. Did Cinco's feedback summary meet, exceed, or fall short of your expectations?
So let's see. So I'm going to generating a summary here right now. So it says, my technical skill is strong and reasonable, and then but my implementation process was fragmented and hesitation, which I felt I think I'm pretty clear. It's more just I was kind of cross-checking with the AI, and the problem solving is very strong. Like the problem definition is clear as well. The communication is like what's the problem it pointed out, like the explanation become less clear as I'm drilling into the code, and I haven't consistently articulate my thought process. This is something I'm going to improve. And also it says I'm using Synco, so which is another pointing out. Let's see my strengths and weakness report. Um, So the strength is that it's problem solving approach and a high level explanation. And I do think that's probably like, what I feel after I hear the question, I kind of get a sense of what this problem is about. The weakness is lack of detailed explanation during implementation, which is right. Like I felt also I was a little bit overwhelmed by Cinco's suggestion, and also, double check my implementation there. And will enhance communication during coding, which, let me see what's my communication improvement it gives. So using examples of searching, supporting details. Yeah, I think I, I could do that. I could probably give a better example of what I mean by graph.
Mm,
Um, and my tone is also pretty passive as well. Um, and I used a lot of filler word. Yeah, I think that's also a good takeaway. I love this feedback.
mm. So would you say it exceeded your expectations?
Yeah, I would think so. It's definitely the feedback is definitely better than I thought.
Okay, cool. And based on your current experience, would you prefer to use Cinco or similar tools in future interviews?
Yeah, I think I probably will use it, even for the sake of seeing this feedback at the end of the interview. And I do feel it gives me something to cross validation while I'm implementing the code.
Okay. And lastly, do you have any suggestions or recommendations for improving Cinco?
I probably will try some way to making sure it doesn't give me too much recommendations, like to overwhelm my communication during the interview.
Cool. That's all the questions I have for you today.
Thank you so much. Thank you for your time.
Yeah. Bye-bye.